Hi, this is Ms. Huang, and welcome to today's math lesson on scientific notation. The do now is point z is shown on the number line. Which value is best represented by point z? Point z is in between 5 and 6. So the best way to solve this is find out what the solution or the value of each of these square roots is and see if it's in between 5 and 6, and then to narrow our choices down from there. So the square root of 5.4 is about 2.32. So we know it's not going to be A. The square root of 29.5 is about 5.43. So 5.43 is in between 5 and 6. The square root of 35.5 is 5.96. The square root of 5.9 is 2.43. So it's for sure not going to be D because 2.43 is not in between 5 and 6. And then we have 5.43 and 5.96. So we can see that Z is closer to the 6. So our answer is going to be C. Square root of 35.5 is represented by Z on this number line. Today's TEK is 8.2C. Our lesson target is that scholars will convert between standard decimal notation and scientific notation, or standard form and scientific notation. Our DOL is given 4 problems. Scholars will convert between standard decimal notation and scientific notation with 100% accuracy. Some academic vocabulary for today is there's 3 parts in scientific notation. The first is the coefficient, and that's a number between 1 and 10. The second is the base, which in scientific notation, it will always be 10. And the third part is the exponent, which is an integer. So it can be positive or negative. Standard notation refers to the decimal form. Like if you were to multiply this out, what would it be? So for this example right here, we have 1 times 10 to the power of 2, which would be 100. So 100 in this case would be the standard notation. And power is another way to call an exponent. So for example, I could say that I'm raising 10 to the power of 2. Another way to say that is 10 squared, because anything raised to the power of 2 is also considered squared, and the number 2 is the exponent. So scientific notation is a method for writing very small or very large numbers using the power of 10. Again, the coefficient has to be a number that's greater than or equal to 1 but less than 10. The base is always going to be 10 in scientific notation. The exponent is going to be the power of 10. It can be positive or negative, and it tells us the number of places the decimal point moves. An example of a number in scientific notation is 1.4 times 10 to the power of 5. If we had 20 times 10 to the power of 4, this number would not be in scientific notation because the coefficient is not a number in between 1 and 10. So to make that into scientific notation, we'd put the decimal point in between the 2 and the 0. So instead of 20, it's 2 or 2.0. And then our exponent would change to be 1 more. So instead of 4, it's going to be 5 because there's an additional decimal point that has to be, or decimal place that the decimal point has to move. There was a matching activity where you had to match the parts of the number in scientific notation, 4.5 times 10 to the power of 4, with their correct label or name. So 4.5 should have been the coefficient, 10 is the base, and 4 is the exponent. Then there was this journal entry. So scientific notation is a compact way of writing very large or very small numbers. We have 4.5 times 10 to the power of 4. So 4.5 is our coefficient. Ten is going to be our base. And 4 is going to be our exponent. And then in terms of positive exponents, when we have a positive exponent, we're moving the decimal point to the right, and our number is going to be greater than or equal to 1. So our number in standard notation or standard decimal notation is going to be greater than or equal to 1. And an example of that is the example that we were just given, so we'll just rewrite that, 4.5 times 10 to the power of 4. And if we were to actually move the decimal point 4 places to the right, we'd get 45,000. And then for negative exponents, we're moving the decimal point to the left. Our number in standard decimal notation is going to be between 0 and 1, and that just means less than 1. An example of that would be 4.5 times 10 to the power of negative 4. And if we moved our decimal point 4 places to the left, we'd get 0.000045. For this first I do problem, we have to multiply the following numbers. So 2 times 10 is 20. 2 times 100 is 200. 2 times 1,000 is 2,000. And every 3 numbers from the right has to have a comma to separate. 2 times 10,000 is 20,000. 2 times 100,000 is 200,000. We're also going to write the equations in scientific notation. So 2 times 10 is the same thing as 2 times 10 to the power of 1 because 10 to the power of 1 is 10. 2 times 100 is 2 times 10 to the power of 2 because 10 to the power of 2 is 100. 2 times 1,000 is going to be 2 times 10 to the power of 3 because 10 times 10 times 10 is 1,000. 2 times 10,000 is going to be 2 times 10 to the power of 4. 2 times 100,000 is going to be 2 times 10 to the power of 5. And as you can see in this example, when we have a whole number as our coefficient, the exponent tells us the number of zeros that are behind that whole number. This IG problem reads, the sun is at an average distance of about 93 million miles away from Earth. Write this number in scientific notation. So our first step is to make this number into a number between 1 and 10. So I'm putting the decimal point in between the 9 and the 3 since our coefficient has to be between 1 and 10. So we have 9.3. Our second number is always going to be 10. And we have to move our decimal point to the right since the decimal point's all the way at the end. And we're moving it 1, 2, 3, 4, 5, 6, 7 places. So 93 million is 9.3 times 10 to the power of 7. This we do problem reads, an adult blue whale can eat about 40 million krill a day. Write this number in scientific notation. So our first step is to make a coefficient that's in between 1 and 10. So I'm going to put the decimal point in between the 4 and the 0. So it becomes 4.0, which can just be simplified to 4 times 10. We're moving our decimal point to the right all the way to the end of the number. So 1, 2, 3, 4, 5, 6, 7. So that means that 40 million in scientific notation is 4.0, or just 4, times 10 to the power of 7. This next I do problem is a bee sting delivers about 0.00005 grams of venom. Write this number in scientific notation. So our first step is to make our coefficient a number between 1 and 10. So to do that, I'm going to make it 5.0, or just 5. And we know that our base has to be 10. And because the number is less than 1, or we're moving our decimal point to the left, we know that our exponent is going to be negative, and it's negative 1, 2, 3, 4, 5. So it's negative 5. So that means that 0.00005 in scientific notation is 5 times 10 to the power of negative 5. This we do problem reads, a typical human hair has a diameter of 0.000025 meters. Write this number in scientific notation. So we have to make our coefficient a number in between 1 and 10. So that's going to be 2.5. Our base in scientific notation is always 10. And we're moving our exponent, or not our exponent, our decimal place to the left. So our exponent has to be negative. We're moving it 1, 2, 3, 4, 5. 5 places to the left. So that means that 0.000025 in scientific notation is 2.5 times 10 to the power of negative 5. Then we have a time to climb activity with 3 questions. It's like a little quiz or Kahoot type question. Then you have to write what is the scientific notation for a population of 930,000 people. Then we have the problem, an ordinary quarter contains about this many atoms. Write this number in scientific notation. The distance from Earth to the moon is about 384,000 kilometers. What is this number in scientific notation? And lastly, our DOL, which is in a Google form. There's 4 problems. Thank you for joining us and following along in today's lesson, and see you in the next math video. Bye.